Looking at this example here, suppose x is a normal random variable with the mean being 50 and the standard deviation being 5. Find the probability, or find the value of the following. So the first one is the probability that x is less than 60. So the first thing you're going to need to do is change this into a z distribution. You want to say, okay, well, if the score is 60, what's that for a z-score, which means that z would have to be less than a certain amount and go from there. Well, for A, the probability that x is less than 60 is going to be calculated from me doing 60 minus 50 over 5. So z is going to be less than whatever that equals, and that happens to equal 2. So I'm looking for the probability that z is less than 2. So when I come back to here, and I'm going to go to the positive z table, I'm looking for the probability of being less than 2, 2.00, so that's 9.7 or 0.9772. And that's what the probability is. So the probability of being less than 2 is 0.9772. Now try the same thing with the probability of x being greater than 43. This one's a little bit trickier. Well, there's two ways you could actually handle this circumstance. But the first thing I'm going to do is translate this into a z-score situation. So I'm actually looking for the probability that z is greater than 43 minus 50 over 5, which means that z is greater than negative 1.4. Now, one thing I could do is say, okay, well, first, I'm looking for the probability essentially in this circumstance, and I'm going to draw it in the banner up there. In this situation, I'm looking for the probability. Here's negative 1.4. I'm looking for this area on this side. Now, one way of handling this is say, okay, well, if I just find this probability in here, and do 1 minus that, that should give me the area that's over in that side. So that's the first way I kind of showed it. So I do 1 minus the probability that z is less than negative 1.4. And so I go to the table. I want to go to the negative table, so I want to go to the first one. I'll just change it to see another color. Negative 1.4 is right here. 0.0808. So my probability is going to be 1 minus 0.0808, which is going to be 0.9192. The other thing I could keep aware of is that, well, the table does give me a circumstance where I have 1.4 on this side and I get this entire area. The table will actually give me this. And I have to realize that should be the same as this area over here because of the symmetry of this thing. So, being less than 1.4 should be the same as being greater than negative 1.4. So if I thought of this as being, the probability of z being less than 1.4, and again, using the table, instead I would go to the second table and say, okay, 1.4, and I'm looking for less than that, you can see that the 0.9192 is the answer that's there. So there's different ways to approach this based off of how you interpret the table. So you have to make sure that you are interpreting the table carefully. Well, since I'm running out of some room over here, let's move to the left for this one. So I'm looking for a circumstance where, one score is below the mean, the other one's above the mean. So if I knew if it was a different location, how I would handle it is differently, but this is really no different than I would handle it before. I'm going to do the probability of x being less than 58 minus the probability of being less than 46. It's the less than 46 is this part right here. So if I lop that part off, that's going to give me the probability between these two values. But again, I can't use the table to figure it's not based on the x's, so I got to convert these to z-scores. So This is actually the probability of z being less than whatever 58 minus 50 over 5 is, minus the probability of z being less than whatever 46 minus 50 over 5 is. And that gives me the probability of z being less than 1.6 minus the probability of z being less than negative 0.8. And when I look these values up on the table, I get 0.9452 for the probability of being less than 1.6. And I get 0.2119 for the probability that z is less than negative 0.8. And of course, when I carry through that subtraction, I get 0.7333.